So we are now at the point of this chapter of our conversation to be able to talk about how to use a Lewis dot structure and its shape, its molecular geometry, to say something about the polarity of the overall molecule. If you remember from the previous videos, we introduced this concept of polarity as being an uneven distribution of charge in a covalent bond that occurs due to differences in electronegativity between two atoms. And we talked about how to calculate the difference in electronegativity of a bond to determine if that bond is polar or not. Well, now we're going to use this concept of polarity to say something about the polarity of an overall molecule. And so to do that, we need to do the following steps. Again, it all stems from the Lewis dot structure. First step, draw the Lewis dot structure. And we'll do examples in lecture. We'll do 2 examples in the next video. Draw the Lewis dot structure. Second step, determine the shape. Determine the molecular shape by determining the VSEPR notation from the Lewis dot structure, and then looking at what the shape is. Third step, if the bond or if the molecule has polar bonds, indicate them on the molecule by drawing the appropriate dipole. And you will have electronegativity tables for the exam. Make sure that you do memorize the 3 classifications of nonpolar covalent, polar covalent, and ionic. And then you're going to use the shape and the bond dipoles to determine if that molecule has an uneven distribution of charge within it. And so how do you do this 4th step? In general, and I should have a star on this side, on this part too. This whole slide is a star. In general, this is a good rule of thumb with 2 exceptions. In general, if your central atom is attached to atoms that has bonded groups that are identical, meaning all fluorines or all chlorines or all hydrogens, and there are no lone pairs of electrons on that central atom, then the overall molecule is nonpolar. Everything else, if you have atoms, terminal atoms that are different, or if you have lone pairs of electrons on the central atom, then the molecule is polar. There are 2 exceptions with regards to XeF2 and XeF4 with regards to their shape. They're kind of shown in these 2 figures here. So that's just kind of a summary of how to determine polarity for a molecule. In the next and final video, we'll start with this slide and then we'll do 2 examples in determining polarity of molecules.